Okay. I'm going to open the applet.
So, yeah, I struggled with this. I've been working on it for days, and I've got answers for ones that I did. But I didn't submit the quiz, so I have no clue because I just gave up.
Yeah, I've done a couple. I've just literally started looking at it like 15 minutes ago, and I've looked through a couple.
Yeah. So the ones I was saving for SPSS, my internet was down all day yesterday, so I didn't even.
Yeah, I had trouble too with my internet.
They said somebody had cut through the entire power line and 253 homes were out.
Oh my god.
That happened in Rexburg for 3 days. We had no internet, and it was snowing as well. One time, it was crazy. Someone accidentally cut it or something.
How on earth do you guys get your homework done?
Yeah.
We had to go to the library. Like, it was mostly just like optics, which is basically used by every single apartment complex ever. But Blue Rim worked, and on campus they worked because it was all wired.
That's good.
So you just went to
my friend's house.
That's a nightmare, man.
But,
so it's chapter 15, right? We're on chapter 15.
Chapter 15. They have like a little. It's kind of nice actually, the review, but it doesn't really help. But I just always open the summaries, and I've been looking at those, and then I can always go back to like just open the new chapter because they have on the top it says hide summaries or show summaries, and it has the summaries for each lesson in Unit 2. But I guess you said, Christina, there've been stuff you've like forgotten from the first part.
Yeah, so I'm really good with the week if I can do it for the week, but then when I have to go back and find what I was actually doing.
Same, it's gone. Like I got an A in Maths 108, and I'm like, I remember anyway.
Yeah.
I got to study for the test and I'll get it done. Okay, right. So question, so we've done the loop group meeting. Question 2, given a 90% confidence interval of 45, 105 for the mean heart rate, which of the following is the best interpretation of this confidence interval? Well, 90% of people heart rate. 90% confident the true mean of the heart rate is between 45 and 105.
So you think, I thought it was A, but I haven't even tried to see. So hold on real quick. When we did her oh wait, what did they do? Dang it.
Huh?
Oh, so I printed it out earlier from the thing and I didn't print it from the quiz. So they switched the answers around. So hold on real quick.
Oh.
You said we are 90%, which one did you say?
We are 90% confident that the true mean heart rate is between 45 and 105.
That's the one I have. It's just in a different order. Okay.
Awesome. No, that's totally fine. Yeah, it's probably a switched orders.
So true. Okay, I didn't do this one.
Okay, do you mind me reading out loud?
Oh, yeah.
So, researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the student to respond to a particular stimulus and not respond to other stimuli. Question 3, the researchers decided to construct a confidence interval to determine if the difference of that means is significant. To determine whether the confidence interval would be reliable, they would create QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I would say yes.
We don't need data. They just want us to read this information. Okay.
Yeah. Yes, the distribution is normal. Yeah, I would say the data is determined to be normal. Yeah, approximately normal. I would say it was number 3 on the way down. Yes.
Mm-hmm.
I wasn't sure because of the 20 and 15.
Because that's pretty. If you add them together.
Yeah, it's 35. So I just wasn't sure. I'm like, okay, is this the separate one where it's the 2 individuals?
Yeah, and then on like the third line, it says both random samples and see that they're approximately normal.
Yeah.
Yes, the distribution of. So I would say yes to that one.
Mm-hmm.
Oh, I don't know. I think I struggled with this one. I wasn't sure. Of the 4 types
the second one could be true. That could be, if this one's wrong, then do you think we'll try the last one?
Oh,
I think you're right with C. I think you're right, but let's say it's wrong. Do you think the D would be the?
I think it's definitely yes, because I think it's definitely
Yeah, I think you're right because they said here the data is normal.
is normal. So it might.
Yeah.
Of the 4 types of confidence intervals listed below, which one is appropriate?
Sure.
Let me look. Hang on.
The means. Okay, so we know the means.
More sigma. Let's see. No, we don't know sigma. So,
Mean is no.
is it B?
It's okay. That is.
I have no idea. I don't know why I'm struggling with it.
I was thinking D, but I don't know. Do we know?
I don't think they gave us sigma. But maybe I misread. Let's see here. Let's make sure. Wait.
Sigma is standard deviation, right?
Yeah,
No, wait.
Sigma is the U, isn't it? Sigma mean is the U thingy.
Yeah.
Mm-hmm.
So we know that, or did we? Did it say that? Confidence means. Oh yeah, but we don't know standard deviation.
Yeah, they didn't tell us. So, and it could be C though too. I don't think it's A or D, but
I'm just going to quickly look in the book.
read it really quick. Oh, it's saying construct a confidence interval. So there's good chance that oh yeah, all of them say confidence interval. Never mind. Sorry. It's not. It wouldn't be.
It's not a dependent sample, right? Because they don't depend on each other.
Yeah, they're randomly selected, so they don't depend on each other. It could either be, I think it either could be B or C, the confidence interval from you when sigma is unknown, or confidence interval for the difference of means using independent samples. But usually if there's a difference of means, like it could be C, because when it's a difference of means, they have 2 different sets of data that are independent to each other, and then you use the it's mu, or when they say that, it's usually 1 set of data. Is that right, or?
No, I don't know why I'm struggling with this one. Well, how about we just go past it and
We've got multiple times to test that one, right? We can each put an answer.
yeah, exactly. There we go. Yeah, we can do it 3 times.
Yeah. Oh, okay.
That makes sense. Okay.
I'll pick C. Okay.
I'm just gonna put the last one. I feel like the last one. Okay, question 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08, 4,000 or whatever. Anyway, which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? Obtain the balances of 90 bank customers rather than 30?
That'd be smaller, yeah. I know that I know a 99% confidence interval on the graph is smaller. So, but I don't know that that's going to change much, or 99.
So if they have more, then it's even a smaller
margin. That works.
Isn't it when you make the sample size larger, your margin of error gets smaller rule?
Yeah, we can do that.
Or is that a rule?
Yeah, obtain the balances of 90 bank customers rather than 30.
I agree. I think it's that one.
Yeah, I think so. Okay, information. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shaft. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of shafts. Input your answers for the margin of error, lower bound and upper bound. I'm just going to go to my calculator and my phone.
Yeah, so, darn them. I hate when they add in this stupid margin of error. I got the upper bound and lower bound. I know what those are.
Do we need the data from SPSS, or is this a by hand?
This one's just the subtraction and addition one.
Oh, okay. The x plus or minus z times standard deviation divided by square root of n.
Say it again.
X plus or minus z times standard deviation divided by square root of n.
I did x times standard deviation divided by square root of n. So yeah, if that's what you just said, sorry.
Okay. So 1,000 plus or minus 1.96 times. They were nice with their numbers. Thank you for making them.
Yeah.
Oh, hi, sorry. I don't know why I cut off.
I didn't even know, sorry.
Oh, it's okay.
I thought you said you were going to get a calculator, not food.
Oh, that and chocolate. Got the calculator and some chocolate on the way.
You know what's kind of weird is the margin of error when I calculated it. I divided it by 2. It ended up being 1.96. Is that right?
Yeah, well, that's a Z-score for 95%. 1 point.
Yeah, but I got the margin of error different than that, but I always screw up on that one. I was thinking it was upper bound minus lower divided by 2. But I don't know that I'm right on that.
I think it's one with the formula.
That means, so what did you guys get?
I got 1.96 for margin of error.
So what is it? Z-score times. Oh wait, I have to put that in.
95% is 1.96, right? For that.
Yeah.
And then,
So I always do my lower and upper before I do my margin of error.
Oh.
So I did the 1.96 times 2 divided by square root of 4. So I may have got that wrong. I just, when I had done it, it gave the A, B, and C
divided by
multiple choice. And that's what I got.
No, I think you're it's square root of 4. Sorry, and then parentheses. Oh, 1.96. Maybe we're right.
yeah, that's weird, huh? And then
No, yeah, sorry, you're right. 1.96, and then you plus or minus it for your upper bound and lower bound.
Oh, wait. So what do we minus?
Well, I wasn't doing the margin of error. Sorry.
Oh.
I always screw up on that, so I was waiting to see what you guys got.
Oh yeah, no, 1.96. We all of us. Did you get that one as well, Christina?
For the margin of error?
Uh-huh.
Yeah, I didn't know that was margin of error, but that's the answer I got to do everything
And then
else.
I forget how to do the lower bound. I've just been so used to doing it on SPSS.
So it should be your 1,000 plus or minus the 1.96.
6, yeah. And then we round. I'm bad at rounding.
1.96.
Is the upper bound, yeah. And your lower bound's the minus.
Oh. I'm confused. I don't know
Okay.
what.
1,000 minus 1.96 to 998.040.
Oh, okay. And then, but then you add, so it'd be 1,000 plus. Oh, I put times 1,000 plus 1.96. So it'd be 1,000. 1,001.96.
Yeah.
Yeah. I'm
And
sorry.
do we round those?
No,
No, because they just were.
that's just what they are.
So the lower bound was 998.040.
998.040, yeah. Or 0. I guess.
Hopefully. Anyway.
But yes, that's right. 998.04.
I think it's so funny that margin of error is 1.96. That's ironic.
I know. Like the 95%.
That's funny.
Okay, to assess the accuracy of the laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with an unknown mean and standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval for the mean has a margin of error of 0.001.
Okay. So I have the answer, and it hopefully it's right. 3841.
Oh wait! They have a little on the little thing. It gives us options.
Yep.
Oh, that's great. So we know if we're close.
When I printed it out, it gave us options at least.
Yeah, no, it did. Yeah, the printout.
So, in which I got the 38416. It's that the n equals z times standard deviation divided by your margin squared. So 1.96 times 0.01 divided by that 0.0001 squared. But if anybody agrees.
So is it 0.01 divided by 0.0001 and the whole thing is squared?
Correct. And then make sure you're timesing that top part by 1.96.
Okay. Okay. And we square the divided part first, I think, right? Because it's, what's the name?
Yeah, so it's the same. Like I put mine in brackets, 1.96 times point.
Yeah, I think it's 3.
Dad, I'm trying to get my homework done. Please go. I'm trying to get my homework done. No, do it later. I'm doing my homework.
841.
Go right now. We have a
Hey, you guys, this is Marjorie's dad. I just want to say you sound so intelligent. I have no idea what you're talking, but I know it's hard work, and I really thank you for helping my daughter, Marjorie. I think, an English accent in there. Is that English?
Yeah.
I've been to England. I love your country.
Oh,
Just-
thanks.
I'll go now. Marjorie's embarrassed. Sorry. See you later, Marjorie. Love you.
See ya. Oh, parents. Gotta love them.
10 more days.
It's till March. Okay, right. So I would say 38416 with the. I got that with.
Okay, good.
I like that it gives us options. I didn't realize that.
So where are the options? Are they at the bottom?
No, if you go to on the exam review, it gives us some options.
Oh.
Yeah, no, forget it. I can't even talk. The chapter this week on the book.
Yeah, in the chapter it's like a
Online
review.
book.
It's on
Yeah.
the book. Oh.
I had it all printed out when the power went out, so I was able to work on some of it, but not with the SPSS files.
The mean area of question 10. The mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis for the mean are less than. So I think it's the bottom one. So the original is that it's 1250, and the alternative is that it's less than.
I'd agree with you.
So it eats the 1250, right? Just making sure.
Yeah, you have no idea how many times I get on the computer and type in greater than and less than.
Oh no, seriously, I just do. I know that it eats the one that
It
it's.
confused me as a kid, even when it eats, and then I'm like, okay, wait, now some of it's starting to make sense.
So it's the last one?
Yeah.
Yeah.
Oh, okay. Okay.
Statistical test of hypothesis. We see direct.
Oh, I learned this. Okay.
I said the last one, but I don't know if it's right or not.
The p-value is larger than A.
Sorry, A equals 0.05 on the actual question 11. So A equals 0.05.
Oh, I'm totally, yeah, sorry, hang on.
See, the thing is different than the test. So that's where I was like, ah.
Yeah, that's what I was just getting confused. I was reading the test one.
Oh, is the last one?
Well, I don't know. I think I looked it up.
In a test of statistical hypothesis, we say we reject the null with the levels of significance 0.05. Let me just.
I think they're talking about p-values. But I wrote this in my notes for the review. Let's see if this is
5% level of significance. Was that what it was?
Yeah.
Yeah, I would say that A equals 0.05.
okay.
I think so. Maybe I'm wrong. Oh no, this is what you said, right?
I'm like, yeah, that's what I'd say, but we'll see, huh?
A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of 15 from each of the 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use the ANOVA hypothesis to test their question? I'm still confused about ANOVA.
Yeah, ANOVA is like when you test more than 3 samples, but I was really confused on this one.
Let's have a look. What's just that?
I said yes just in the end because the data and the bell-shaped with no outliers
Yeah.
and sample standard deviations are equal, but I don't know.
Have a look. So do you not know?
I think they're trying to confuse us, but usually if it's more than 3, then you can use the ANOVA.
Mm-hmm.
Yeah.
But I don't know which one.
I'm just like reading through the book just to see. I'm always so confused. Golly.
I think it might be C.
Let's have a look.
The yes, that's kind of the direction I'm leaning, but I'm not
Yes,
sure.
it's enough for the data for each apartment building are bell-shaped, no outliers in the sample area. We have a total of 60 GPAs all in one, so they can apply the central. Let me just read about the central limit theorem real quick. Just double check. Central limit theorem. If sample size is large, sample mean will be approximately, normally distributed. Sorry, one sec. My sister is calling from England.
You're fine.
Meg, I'm in a group meeting right now, so I can't chat.
Oh, okay.
Sorry, I'm on Skype. But I'll call you after if I finish. We might be a while though, because it's kind of a long quiz.
Okay, that's fine.
I'll text you. Sorry, love ya. See you. Bye. Sorry. sample size is large, sample mean will be approximately normally distributed. I don't think it's got anything to do with the central limit theorem.
Yeah, it doesn't.
I think, yes, it is enough that the data for each apartment building are bell-shaped, no outliers, sample variances.
Okay, that's what I was thinking.
Sorry, I take 20 years more than everyone else, apparently.
No, it's okay. It's good to
Hey,
check.
why do you think I try and do it before?
I know, I just did
I
it.
get distracted. I can't even think about it.
Okay, a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it's determined that the new treatment does not increase the mean survival time in the population of all patients with this type of cancer. The researcher has... Oh, I bet it's going about the errors.
Yeah, I was thinking it's a type 1, but this is another one I always screwed up on. Because she said it didn't happen, but it really did. She
Yeah.
said, even though she knew that it was longer, she said that it wasn't longer, but then it really was longer, right?
It's type
Yeah.
1 error. That's when you reject the null when the null is true.
Yes, that reject the null when the null is true.
Yeah.
I forgot.
Okay. Type 2. Are we on 14 or 13?
No, we're still on, are we still on 13?
Oh yeah, I think 13 is A.
Oh, you think it's a type?
Oh, type 1.
That's what I thought was a type 1, but it.
Oh no, I'm gonna go with the majority vote here. Then we'll say type 1. That was honestly, I was kind of making a guess. I probably should. I probably have notes.
Oh, it's in less than 9. I knew that much. I wrote down my notes for that. But like I said, this is the one. So let's see. The truth is that she said, forget it. I never can read this graph.
Yeah, it says she rejects the null hypothesis. Yeah, it's A.
Like, never mind. I can't tell you. Okay.
Does everyone agree on type A?
Yeah.
Mhm.
Type 1, sorry.
Type 1, sorry.
Yeah.
What are you getting into, Isaac? The other day after a meeting, I went out and he'd eaten like 10 pudding cups. It was all for kids' lunches. It's like, ah.
Wow. This is a type 1 error. Okay. Yeah, I agree with that type 1 error. So if the level of significance A is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
I think it's, I have to compare. Type 1. I think it's the very first.
By reducing the probability of a type 1 error, we increase the probability of committing it. I agree with that one.
Oh, okay, so it's the opposite.
Yeah.
Okay. How come? Do you guys know or understand that, or?
I just remember reading it somewhere that,
Yeah, I have it in my notes, I think.
yeah, if you reduce it, Let me find it.
Oh, it's just in the book.
Yeah,
Okay.
I think there was a quiz question that was exactly this. For some reason, it just rings a bell to me.
Okay.
If the value of committing a type 1 error is small, the probability of committing a type 2 error will be large.
Okay.
So
I'm gonna write that in my notes. Okay.
Yeah, it's a good one.
Chances are there's probably an exam if it's been showing up a couple times. Okay. By reducing the probability.
Oh yeah, this probably will be in the exam.
Sorry, I'm taking a long time to write down.
Oh no, you're fine. I'm kind of just reading through.
Okay. That's good. Her review helped a lot. Like her video review.
online.
I'm gonna go through it right before again because I was.
She goes through every like SPSS thing to show you how to do it.
Oh, that's great. 'Cause I-
And how to discern the word problem, how to use the SPSS, and then like it's like an hour and a half video, but it's worth it because like she shows you all the stuff like ANOVA and shows you other stuff.
No, that's great.
Because for me, like the hardest part is discerning between if it's a paired sample or if it's an independent sample paired, you know? Like they have a word problem and either they have two samples
Yeah.
and one's the dependent one where they're dependent of each other and the other one's independent where they're not. Like I have a hard time with that because I'm always connecting everything, so everything's dependent in my mind. So I always pick the dependent one. I'm like, no, that one's independent because both of them aren't connected to each other in any way. They're just gathering data from both things, and then
Did you go to it live, the live one?
nah, I just watched the video.
Yeah, I just watched it too.
It's hard to catch her. I never know when they're gonna do it. So
Okay, so the nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. Brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give the sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis at the 0.5 level, 0.05 level of significance. You can conclude that you should.
So this is one that I did, the handwritten one as well.
Okay. Nicotine. Advertises measurements.
oh, is the X plus or minus.
No, I didn't use a plus or minus. I'm trying to find what it's the hypothesis testing. I did the X minus the mu or how the mu with standard deviation by each other. I'm trying to find the actual problem. It's calculating the z-score. So X minus the mean standard deviation. Oh, see, I'm horrible. Here. See if I can find it. Never mind. I can't find it because I'm an idiot.
Oh, is this problem in the book?
I don't know. This is from something I printed in lesson 9. I mean, it is the thing. So I took 1.53 minus 1.5 divided 0.17 or 0.17 divided by square root of 100
Right.
is the X bars. And then I got 1.764 and then entered that as my z-score or my t-score, whatever it was, z-score. And then got my p-value of 0.0389.
389. And this P is low, so you reject the null.
Yeah, I rejected the null.
Yeah, so reject H O, right? H.
That's what I said.
Yeah.
Don't hate me if it's wrong.
No, I think that one's wrong.
So did you do a formula or?
I did a formula. I just can't. I don't know how to say it, and I don't know exactly. It was the formula for the hypothesis test, sigma unknown, one sample. So let's see if she shows that on her cheat sheet. Samples.
Is that the flow chart, the cheat sheet thing?
Yeah, the flow chart. there.
Oh, I have that. I have that right here.
Yeah, pull that out. See, I didn't use it until now. I mean, I've got it, but
I'm gonna pull that up actually as well.
It's hard for me to see the little formula.
It's gonna be one group, sigma known.
Oh, is it x minus u divided by sigma divided by square root of your sample?
Hold on real quick. I may be telling you the wrong one. 0 divided by 0. Yeah, it looks like it's what the Z-score one at the very bottom. Yeah.
Oh, that was a while ago. Okay.
Yeah, the very first lesson we did, one sample Z
Ah. So you plug in those numbers, find the p-score, and then if it's higher,
Yeah, and it was low. It was 0.0389. So it was lower than the significant whatever.
okay, so if it's, okay, I remember that rule. I just have to look at my notes for when we reject it and when we don't. I got those mixed up because in the review she goes over that. And it's really helpful, like specifically like which one you do.
Which one was there? I'm trying to find the. Can you email me that? I had it before. The
You know, she sent it out to my BYU email address, which I never use.
Great. I've got the I have the test review video.
Yeah, see, that's my problem. I always forget everything.
He has a little trick. If P is low, HO must go. If P is high, keep the guy.
Yeah, I think she's just trying to get the cheat sheet.
I can, I've got it right here. Do you want me to snip it and send it to you? Oh, wait, it won't let me. It won't let me do that.
Oh, here it is.
I think it's on the email. She sent it to everyone. Like, it's
Okay.
Yeah, everybody. Did you find it? If not, I can forward it to you. I just pulled it up just now.
I want to see if I
Did
can.
all this fancy stuff to snip it.
iLearn. I'm sure it's on iLearn and the announcements.
It's week 8 notes from Sister Wilkinson.
Oh, man, that would have been, I should have checked my email better.
Oh, there we are. Perf. Oh, I don't know how. It's not very big.
Week 8 notes?
So, and if you click up above it, it says there's a flow chart PDF at the very top or the very bottom somewhere. But unless you're in, I'm sorry, that was the email. I didn't see it in the
I got it.
actual.
Flow chart for comparing means. There it is. How many
Okay.
groups of means can being compared? One mean, hypothesis, something distribution. Okay, that's great.
So it's week 8 notes?
Yeah, week 8 notes. Oh, my back is starting to hurt.
Yeah, I know.
I've been doing this all morning.
Sorry, I'm taking a long time. I have so many emails. Okay.
Okay. Which question are we on?
And 16.
Okay, so we rejected them all. So 16. Right, to look at the mean number of hours worked for wages. How many groups are there?
Okay, 16.
So this is where I get confused. I know we have 2 different groups, but are they compared? Is that one group because they're trying to get the wages, or would that be considered 2 groups? Because it's 2 different people.
Male and
For
female.
each group, 100 for each group. So that's probably a 2 group, right?
Yeah. So
So-
that is
No,
Okay.
it's
or
groups are dependent.
Oh,
Groups are independent.
It's the independent one because both of them are different from each other. They're not
Probably
really.
a two sample.
So it wouldn't be the paired samples t-test?
Yeah, that's what I'd say.
Oh, paired sample t-test?
Oh, so it's the paired sample t-test. They are related.
Yeah, that's what I was thinking. Because there's two of them, so that would make sense.
So is it the independent one?
So it just, are the groups independent of each other or dependent of each other? Do they need each other in order to prove it? Probably not. Right?
Yeah, they don't need each other to prove it.
So it's probably independent.
Samples t-test.
See, this is where I'm just looking at her cheat sheet, but I don't know.
Hmm.
Paired groups. What did I have originally? Yeah, that's not the answer. Originally, it was independent samples test is what I got, but I don't know if that's
Two
right.
groups are dependent, groups are independent. So we just need to decide that. And it's either a paired. Oh. It either says groups. So there are two groups, right?
Yep.
Groups are dependent, groups are independent. And it's either paired T procedures or two sample T procedures. So
Paired is what it looks like then.
paired, yeah. That's good. Okay. This sheet worked, and she said we can use that for the test.
If not, we'll just put the other one later.
The
Oh,
independent.
so it's independent?
No, paired sample T test.
Oh, okay. How come?
Because if you look on the cheat sheet, it says how many groups are being compared. So there are two groups. Are the groups dependent or independent? So when you said that they're oh wait, did you
For
say
paired, it's dependent. For two sample, it's independent.
does it say even two sample
Yeah, I don't see a two sample unless that's independent samples.
T test? But it says it's a T test, so well, we'll do one and then decide. So if somebody wants, I'll put paired sample T test, and if someone else wants to put independent samples T test.
Sorry, these are the one I struggle with the most. I'm really worried about the exam. I'm like, they both seem the same. She said on the exam though, like if it seems like they're describing exactly how they found each one, there's a good chance that they're dependent. But if it doesn't describe it very much, there's a good chance it's independent. So because it's smaller, like it's a smaller word problem, like but that could be a bad guess, but
Males
I'm
and
gonna-
females. She decides to use the brothers and sisters. They're dependent because they're raised in the same home. I think they're dependent. Furthermore, she decides to use only brother-sister pairs. Yeah, because they pair on each other, right?
Yeah, but this is, hold on real quick. Isn't that two different questions or is it one?
Gosh, I was looking at the one below. Excuse me. Wages by male and female students. Sorry, I don't know how I did that.
It's okay.
They're all kind of melting into one question now.
I'm sorry, I probably overthink it too much.
I'm just gonna let's move on and we'll go back. In female system, she says she's brothers and sisters. And furthermore, she decides the only brother and sister to use only brother and sister pairs when they are next to each other in sibling order. She can hypothesize based on independent or dependent something. So I would say dependent because they're dependent on.
I was thinking D, or the very last one.
Yeah, if you select a brother. Sorry, I was just looking at these both. I haven't read it yet.
Okay.
Select a brother so as to compare his academic issues. You must include the sister. Yeah.
I agree. I think it's dependent.
The last one, 18. Oh, here we are. Now we have to use actual.
Yeah, this is where yeah, this is where it might take us a while. Sorry.
Okay, we can do this. Okay.
Yeah, I'm just looking.
Cell samples are random cell samples from a field and measure the dissolved organic carbon level of each sample. The measurements are recorded in dissolved organic carbon. The researcher would like to construct 9% confidence interval for the mean dissolved organic carbon level in the field. me click on it. Go. So carbon levels. It's only one set of data, so and give us sigma. No, this gives the confidence interval. So sigma is unknown. It could be confidence interval for mu when sigma is unknown. But it's only one set. Usually, if it's only one set of data, it's for.
I'd agree with that.
It's a difference of means. Usually, they put like M1 minus M2, right?
I hate how certain things don't work on my computer. I just lost my quiz. I got to go back in and open it up.
Oh,
At least it saves it. It's just frustrating. I'm like, where'd it go?
I understand.
Yeah, one carbon level is one level, one amount of data. If you.
Do you agree? Alice said A.
Yeah.
Okay.
So,
Four types of confident intervals. Yeah, confident intervals for mean when sigma is unknown, I guess. Which are the following?
you know what, that would work because she says the next two questions I use the handwritten, and she says you only do that for the handwritten ones, right?
Mm-hmm.
Which of the following is a 95% confidence interval for this analysis? Input your answers for margin of error, lower bound, and upper bound. How do we do this again? We want to analyze or transfer.
Analyze descriptive statistics. Explore.
Oh, I was going to say frequencies. So explore. Dissolved organic could be.
Dependent lists.
Yeah. Okay. And then we click on statistics.
Yes.
95% is already.
Yeah, so that's it.
Okay. It's processing. So the lower bound is 11.168. We'll go for 11.168. That's
Yeah.
the lower bound. 11.1.
And is this where you minus the margin of errors?
You minus the upper bound minus the lower bound, right? And that's margin.
Do we divide by 2 on any of it?
Potentially.
I think so, yeah. You know what bothered me though was like, I think I put in the right answer and it marked it as wrong, and I was so frustrated because margin of error is one of my weaker ones, and so I was like, did I really get that wrong? So
Did you already submit this, Marjorie?
What?
You already submit it?
No, it's for another assignment.
I was like, well, and then it says STD error is 0.96. Oh, never mind, forget it. Shut up. I don't know.
Margin of error, we minus the lower and the upper bound divided by 2.
Okay, good. That's what I
I
did.
think that's what we do for SPSS, yeah. So I'm just going to do that with my calculator really quick.
So we need the sample size.
Minus 15.7 divided by 2, which is it negative 2.024?
That's not what I got. I got 9.633. Alice, what did you get?
I'm still working on it.
Oh, okay.
So wait, our samples. What was the sample size?
Okay, so I'm obviously doing margin of error wrong. Darn it. Okay. Hold on. Sample size.
Because you have to the square root, right?
Well, this one we're doing confidence levels, not the hypothesis test. Does that make a difference?
Wait.
I hate the margin of errors. Why is that my hardest one? L11.
We're doing carbon levels, right?
Yes.
Okay. So 20 level.
Upper bound minus lower bound divided by 2 should be the margin of error for 95% confident interval for that.
Oh my god.
I don't know if that's right.
Yeah, I keep getting negative 2.02. Maybe I'm doing the calculator wrong.
Okay, maybe our upper bounds are different then. Did you have 15.217 on the upper bound, you guys?
Mm-hmm.
Minus 11.168?
Yeah.
Oh, yeah, but are we supposed to minus the upper minus the lower bound?
Yeah.
Oh, I thought it was lower minus upper bound. Okay.
Oh wait, there are samples. Let me just double check.
Neat.
Yeah, it just doesn't have the margin of error for the sample.
And every time I get 2.024, is that what everybody else got?
No, that's not what I got, dang it.
Man, maybe I'm doing the calculator wrong.
Minus, and you're dividing it by 2?
Mm-hmm. 11.168, then we'll equal it. And then I'll divide that by 2. Yeah, it's the same number every time. It's messed up.
I don't know why they don't show it on the chart.
No.
Okay, so I see what you did. Maybe that's the way you do it, because if I do it that way, it is different. I was just doing that minus, or 15.217 minus 11.168 divided by 2, and it gave me 9.63. So on that, maybe that's the reason I'm having problems, is that I'm doing it that way. So 2.025.
Yeah, but I have a hard time with margin of error too.
Oh, it's not. And then what we do? Hang on, 2.025.
Okay.
Okay, we'll give.
Hang
I
on, and then you just plus. So you can test it by plussing it. 11.168 would equal. Oh, I don't know. I don't know what I'm doing. I just remember learning you can test it, like test if it's the right margin of error.
Mhm.
I don't know, guys, I struggle on the margin of error. So if it's the 2.025 or the 9 is, I guess I could write my 9 down, but I'm not saying anything on that, because that's the one I do get wrong.
So 2.205.
2.025.
Okay, so 0.25. Thank you. Oh yeah, 0.25. I've got that on my calculator.
I hope that's right. I'm not very good at margin of error.
Yeah, no, it's the same thing, except my calculator divides the two
It
different.
makes sense. 11, 12, 13, 15. It makes sense to be around 2. So
Yeah.
hopefully
Okay,
that would work.
cool. I'm all for that.
Okay, random. Okay, I'm going to delete everything on SSPS now because I get mixed up when there's so many.
So I'm like,
I don't even save it, which is probably bad.
I never save it either. I'd have so many things open and saved.
I know, it'd be driving me crazy.
I do a ton of testing. I'm like, okay, that one didn't work. What was the real answer?
Yeah, that's why I never save. I usually don't save mine either, unless I got it right and I haven't had time to finish up the assignment.
Yeah.
So I save it and then go back to it.
Oh, for goodness sake, I have so many things open.
Okay, so we are on used Hummers. Oh, I hate this one. There's so much data in this one, I couldn't even figure it out. I was like, it's got to be ANOVA, but then I couldn't figure out how to even do the ANOVA.
Yeah, it's not ANOVA.
Okay. I tried like 5 different things. I could not figure, because I have a figure we have to transform something.
I hate this one too. It's either independent or paired sampling. I think it's paired sampling. I got an email from her about how to do paired sampling, so if we want to do that, we can. I think that's the one. Because I was sitting there racking my brain, just staring at, like, trying to figure it out, following the instructions. And what's weird is in the book, for the chapter, there's no instructions on paired.
Do you remember what lesson that is?
I think it was like lesson 13.
14. Okay, sorry.
I'm 14. Yeah, and it took me forever. And finally, I got fed up and emailed her, and she helped me. She helped me show me how to do the paired sampling. But they need to have a better paired
Yeah,
sampling.
that's the one that's you transform, right?
Yeah. We go to transform. We go to automatic recode.
Yeah, and so I had done price, but then when I changed it, what did you group code?
We would do year, and I put Y code, probably do that.
So the year?
Oh,
How
yeah.
come the year? Sorry, I need to find my other thing.
Sometimes it doesn't work because it's dumb.
Okay, so I'd help if I get to the right problem.
Okay, group code work. Then we go to,
So how come you chose the year? Because I don't even see that listed in here. I'm working with the year. Maybe it is.
you do paired samples, and then that's mileage. Let's see. We could do, let's see here. Oh, here's a list of what ones it could be. They give you a list.
Yeah, so that's what, but usually you can only group code either the rulers, whatever those things are called.
Oh, ow. Sorry, I just hit my knee. Right on.
I think maybe not. I don't know.
So the sigma's known, right?
Mm-hmm.
Sorry, it's still loading and opening up. It's opened up blank ones.
Oh, I hate this program so much.
I don't know why we
I'm sorry.
didn't use Excel. Doesn't make much sense.
I don't know. Yeah, she said this is a better one because it's specifically for statistics. So I'm going to be happy. At least we have automatic. If we figure out how to do it, you can figure out the right numbers.
Oh wow, there is so much data.
Yeah, see, that's what I'm like, I have no clue. I tested a whole bunch of them last night. Couldn't come up with anything.
So what I do is for the
Yeah,
year,
I got something. That's
usually the first one, the first column is your group. Like you want to find the group and you recode your group. Like I put Y code or group code or whatever for the group, your group of things. And then you use the price and the mileage for
I found it. Oh, I don't know what I just did, but I got the answer.
paired data. You go to paired samples. I could be wrong in how you do this, but you go to the paired samples t-test and then you put your two variables in, like the mileage and the price. And then you click on OK, and then it has data come up. But I could be wrong with that. That's what I'm assuming.
So yeah, I found out how to do it. I'm glad. If she hadn't told me what test to do though. So what I transformed was the city group and made that into the group code.
So you automatic recode, right?
Yep, transform automatic group code. So the city was the group code.
Oh, the variable?
Yeah, for the variable, and you make that into your group code.
And the new name would be what?
Whatever you want. I typed city group code for myself to remember.
Okay.
I'm glad Marjorie knew where to go.
I used year. Does it matter?
I couldn't get it to pull up in year, so that doesn't mean that it didn't, but I just didn't understand why we needed to do year when we were searching for the city and the price.
Oh.
I didn't know why the year would make a difference.
That makes sense. Okay, I'll do.
So because we had those 4 options from the textbook, so I was able to find one of those. Then what did it? Compare means, and then it was the independent samples t-test. And I did test variable price and then group code, which was your seller. And I can't
Okay. Oh, Erin. Hey, I thought you were gonna come over to dinner. Oh, okay. Oh, sorry, I'm doing homework. Sorry. Okay, so we go to automatic code, use it for city. Okay, that's really helpful. So read in the word problem the details about what they're asking for.
So, and do we always use the bottom on this, right? And so then it should be your,
Oh, I've realized I've been muted this whole time. I was like, why aren't they listening to me?
Oh no.
I didn't even pay attention because I'm looking at my screen, sorry.
No, it's totally
I'm
fine.
Mine too. So like, which
So
one
we
did you
have
guys?
to analyze, compare means, and then which one do we use the
Independent sample t-test.
t-test? Okay, and the test variable
Is,
city, and then the grouping would be the city group code.
okay, sorry, give me 1 second. I want to say yes. Yeah, the test variable is your price.
Oh, price. Oh god, look at that. And then options.
Oh, I don't think it's this one. It's not. This isn't how you do it.
It's not, because it's part of the answers that we got that she gave us in the multiple choice, so I just assumed it was.
Oh, it is? Okay. This is how we do this one. Okay. So you just put price?
Oh, and you define groups: group 1, group 2.
Yeah, for your group code, and then
Continue. Okay.
and so then it's either I thought it was the equal variance is not assumed, because I think that's what they wanted us to do.
Mm-hmm.
So the negative 423.158 and 5417.256. Is that what you guys got?
So for test variable, do we put, I'm sorry, I'm a little behind. Do we put mileage and price or just the price?
Just the price.
Okay.
So hang on.
Oh, so we just read the instructions very, very carefully, and then that makes sense. I have a hard time reading it carefully. Okay, so
423. So it was minus 423, 1.58, right?
0.158.
Oh yeah, sorry. And then upper bound is 5417.256.
Do you guys agree that it's the lower? I can't remember for sure, because the upper also was part of those that could work too, but I thought it was the lower. I thought they always said not assumed.
I remember her saying like the top one isn't the valid one.
Okay, that's what I thought too. But I don't want to go through
Yeah,
my
the
notes.
bottom one. Yeah, you were right about that.
Okay, good. Lower bound.
So let's do it. So this is, what did we decide for question 22?
Marjorie has that one. She's the one that led us in this direction. Did you say it was confidence interval for mean
When
when
sigma is
standard
known.
deviation is known?
Mm-hmm. I think that's the one.
So that's what led us to this, which I feel is right because we actually had answers.
Yeah, and they can't paste. So it was, oh sorry, I have to keep going from what the,
Like how? I haven't saved for a long time.
so 423.158, right? Minus 423, sorry. Minus 423.1.
Correct.
Double check. Sorry, I'm having to go back and forth, so I have to remember. 5417.256. 5417.256. Nice.
Oh, we are almost done.
Okay.
Oh, so we can get off this horrible huge thing now.
Hopefully it was right. If it's not, I'm sorry guys, I'm gonna pass on it and just say forget that.
Oh, I think you're right. I really do. I thought it was the third one, but it's not. It was because the thing that I like about that though too is they ask you first what kind of test it's going to be. Does that make sense?
And that's
I'm
where
sure they'll do an exam where they'll be like, okay, what kind of test is this? Click on that one when you think it is, and then you solve it based off of that one.
see, that's where I struggled. So when you told me that was the answer, I was like, okay, gotta find it, and it matched because that's like the only thing I didn't try.
Yeah.
Got Marjorie.
You picked the right one. And hopefully they won't have on the exam like every single test that you could possibly choose. They'll be nice and put like 3 or 4 different tests that might be good.
Easier exam too. Not for me. Not for me. Okay.
Okay.
We lose Alice again.
No, I'm here.
Yeah, okay.
Okay.
So we're on 25, right?
Mm-hmm.
I think it's ANOVA, this test.
That's what I wrote down was ANOVA.
Because there's more than 3.
Yeah.
I like ANOVA. I
Sorry,
understood it.
if I'm silent, it's either because I've been accidentally muted or I'm just thinking.
You're fine.
Okay. Okay.
Earlier, so I didn't realize I was muted, so I was like, oh no. Okay.
Usually it's okay. Let's-
Oh, this is one I couldn't do either. Sorry. Okay, so we agree that it's ANOVA. We can get from there, right?
Mm-hmm.
Yeah. So we need to find the test.
We have to transform and auto recode, right?
Yeah, it's just loading for me. Give me a sec. So I can do it with you. Then. So yes, this is the double check I've got the right stuff. Bone density exercise. Okay, and there's only 2 groups. This is good. Oh wait.
Yeah, I like the ANOVA test. The ANOVA test is a good one.
Okay, so transform, automatic recode, and then the variable would be the treatment,
Yeah, it's the treatment.
and then the new name we'll just put just group code. Add new name. Okay, we just click OK, right?
Yeah.
And then this is when we do the analyze, compare means, one-way ANOVA.
Okay, I learned something from the teacher. F means the test statistic for this.
Yes.
So
Yeah.
it means I got so confused with that. I was like, oh, what's F?
Yes,
And then,
so the dependent is rat bone density and the group code is the factor, right?
mhm.
And then we can just press OK then. F 7.978. Everyone get that?
Hold on real quick. I'm behind. Sorry. If you say so, I'm on.
Yeah.
7.978.
Yeah, that's that one.
Yeah, I got it. Okay.
So calculate 7. Sorry, I'm 7.9.
Value 0.002.
Oh, that's the p-value.
Yeah,
Yeah.
0.02, yeah.
Oh yeah, so it's sigma. I always forget that. So 0.002. Oh my gosh, we are so close.
Almost. Okay.
I have a test statistic 7.978.
Oh, which of the following best expresses the conclusion of this test? Oh, darn it. I don't like
Oh,
it.
yeah.
The p-value, okay, I've got the notes for it. If p-value is low, HO must go. If p is high, keep the guy. So
P
let's
is
look at
low.
value is lower.
Yes.
So HO needs to go. So we reject the null hypothesis.
Yeah, we gotta figure out the sufficient evidence.
Oh, wait, and I know there's a sufficient, insufficient thing. Where is my... If
I
it's,
think if we reject the null, then it's insufficient maybe, but
no, I wrote this down. There's like a rule.
oh, there's a way of knowing. Okay. What is it?
We have sufficient evidence. So if we know it's sufficient,
Oh, when reject, then it's sufficient.
yeah, okay, so which one? There's 3.
Sufficient- Oh, no, it's just... Oh, there is...
So if the at least one group is different, because that's what ANOVA is, right? It's the
Um,
A, B, C,
no,
D.
no.
Is it the D?
All groups are different.
So if the p-value is low and we reject the null, then it's insufficient. If the p-value is high and we accept the null hypothesis, then there is sufficient evidence. Is that
Okay.
right?
Oh, so it's insufficient.
See, I thought if we rejected the null, it was sufficient.
Yeah, reject, then sufficient. That's what I've got written down. When reject.
Did we reject?
Okay, so if we reject the null, it's sufficient.
And then ANOVA is at least one of the groups is different. So wouldn't it be, isn't that what the ANOVA is?
At least
So-
one.
so-
Oh, so it'd be A, B, C, D.
Right.
There's sufficient evidence to conclude that the mean bone density of at least one group is different from the mean bone density of one of the other groups. I'm going to go for it.
So if the p-value is low and we reject the null, it's sufficient?
Yeah.
Okay,
Oh,
that
guys,
really helped me. Thank you for helping clarify that.
Okay, and then we get rid of, we're done this, so let's close it and start this new one, and then that's it. Sorry, I'm really excited. Even though I'm doing the test tonight, I'm like,
I hope that we're right.
yeah.
That's what I think. I'm like, only 4 more. I thought that was the last one for some reason.
Oh, I'm sorry.
It's my fault. I was like, oh, that just ruined it.
Okay, pressures of supply and demand on the price of the airline tickets. Oh.
Okay. Got the flights. What is, let me read it really quick, see what it is. Okay.
So I think this is a paired samples. Stop.
Mm,
Oh, there was a problem like this on the homework.
Yeah, that's what I'm checking right now to make sure I got it right.
Would it be dependent?
Yeah, I believe it's the dependent samples test.
They need each other? Okay.
So let's see. Oh, that would be really good if I got that.
And we do automatic recode, right?
Yes. Oh, good. I got the answer. Woo-hoo!
So it's dependent samples test.
No, not an automatic code. Sorry, it's transform and compute. Yeah, so this will be your
Compute variable.
sample t-test.
Oh wait, it's the file didn't open. Of course it didn't.
Wait, hold on.
That did not happen during the test.
Oh, we're using the one sample t-test, then it can't be the dependent samples test. So I screwed up somewhere. I've got the answers, but I can't have used the one sample t-test and have a dependent samples test.
Do we automatic recode for this one?
It depends on what you do. So what test, like I got an answer that's in our list using the one sample t-test, and I just used transform and compute.
Okay.
Because we have differences, and that's what we did in one of the assignments.
Mm-hmm.
90 days minus the 14.
Sorry, it's not opening. Just keeps opening up. Oh, so frustrating.
Oh, I emailed the professor with this question on how to solve this kind of question. You want me to look it up? I think this might be the paired one, but maybe I'm wrong.
I got answers. I don't know. Like I took the difference. You did the 90 days minus the 14 days, and then you compared means with the one sample t-test, which gave me.
Oh, is this compute variable?
Yep. You have to go to transform first, though.
So is this the dependent?
Yeah, this is the one that I can never get my SPSS to work because yeah.
I don't know why. This is okay. Now it might actually be working. I had to completely quit out of it.
This doesn't work. Okay. Do we need to do, yeah, I think I need to do an automatic.
The transform compute variable, target variable. Oh gosh. What is our target variable?
Like difference,
Huh?
difference.
Yeah, you guys are doing one different than I'm doing.
Oh,
So, I mean, if you guys come up with it.
well, no, we should.
It
choose
never
some.
works when I do this.
Are you on compute variable?
Yeah.
Type in difference.
Right, there might be a, what they do right. What we do right. But you're not.
So we do one minus the other. Which one would we use? Or is
It's your 14 days.
oh perfect. Oh
Right.
darn. Hang on.
And do we do an independent samples t-test for the minus or for the difference?
No, not
All about that.
sample t-test.
The one sample t-test. Okay. And then you put in minus. And do they have a test value or?
Sorry, are you on the, you're already on the t-test. This
Okay,
is
so
a
we've
good.
got the difference now. So we got the test value. We got analyze, compare means.
Correct. One sample t. So
Yeah.
your test variable is your difference. And then there's going to be anything else we change.
Okay. 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 So, what is the test value? One sample test. I only have two little, one sample statistics and one sample test.
Yeah, so if you see the one sample test, it is the only one that has a t-score.
Oh, I didn't see that. I thought it was a D for some reason. So minus, let me just look to see if it's,
So, and I don't think we can have a minus. So 1.685 is on there, but not a minus 1.685.
oh, okay. So we're just,
So I don't know.
So when you do the one sample t-test and you put in, you know, your differences, is
right.
there a test value that you put in for the bottom part or no? Because it doesn't say, I don't know if it says test value for
It doesn't
this.
say in a p-value either. I don't know if it's-
Your p-value is your sig.
Oh, I always forget that. 0.096 and double check.
It's really, really close to the indent. Can you give me a couple moments? Yeah, you could try that, sweetheart. You have to press the square twice.
0.096 is the p-value. One more, guys. Should we just put what?
See you guys.
Should we just put 1.685 or negative?
Yeah, I don't know.
Can you guys hear me?
Yeah, we can now. You were breaking up for a moment.
Okay. I had a question about, so you used one sample t-test, right? And you used the difference for your test variable.
Yeah.
Now, for the test value, do we put anything in the test value or does it?
I put them in there. They're in a white baggie.
Hold on. Are you on the one sample t-test you're asking?
Mm-hmm, yeah. Because
Um,
it doesn't say anything here about having a test value, but
So your test variable, is that what you're asking?
the test value, you know how you have the test variable for your differences, like the
Yeah, your test value, no, it shouldn't be anything, not on this one.
Going to be a test value for this one. Okay, it's only a test value if it's like H is greater than this big number or equal to this big number. Okay. Okay, now it's all okay.
Which of the following best expresses the conclusion?
No, not the red dot.
Go to the loo right now, so I'm not focused.
So our test, so I'm a little behind. So it's 1.685.
Yes.
Yes. And then the p-value is 0.096.
You're gonna look for something like this.
Double check to see if this is one-tailed or two-tailed. And one-tailed has like a greater than or a less than in the problem. So let's double check to see if this is one-tailed or two-tailed. And it doesn't really have any null or hypothesis or anything like that.
Yeah, and if you divide it by 2, there isn't even an option for a 0.48 on the test itself.
Yeah. Oh, I hate that.
So I don't think that it is.
That's gonna drive me crazy. But hopefully
Do
they
you mind
have
if I quickly
formulas
just go to
right
the
there.
bottom Zach?
Yeah. I was thinking it's the number B or letter B.
It's the two-tailed. How do we know it's two-tailed?
I don't know.
Let's look at our null. Pressures of supply and demand act early on the prices for an airline ticket as the seats available on the plane begin to fill. If there's any like use in advance status clicks on a crystal ticket.
Okay, I can't talk to you right now. There is no difference, or there is a difference.
I would think that it's two-tailed. I think it's two-tailed because there's no equal. There's nothing in there that talks about anything equaling anything. It's just is this greater than this or is this greater than that? Does that make sense?
Okay,
So I would agree
look for a
that.
triangle. Maybe try a triangle. See if there's a triangle. Okay, so it's either B or C.
Hey, I'm back. Sorry.
I think it's two-tailed because usually if it's one-tailed, there's a greater than or less than if it's one-tailed, and then if it's two-tailed, then there's not an equal sign, and there's like an equal sign and there's a slash when you're looking at it. That's what I got from the notes. So sorry, I've had a real rough time trying to discern if it's one-tailed or two-tailed, and that can make or break through, see if it's right or wrong answer. You know what I mean? Like you can get all the work done right, and then you not do the one-tailed or two-tailed, and then it's not the right answer. So on here we can guess, you know, but on the exam we can't guess. So that's why I'm kind of having a hard time with one-tailed, two-tailed. But
Okay, sorry, what number are we on?
we're on number 31.
Oh, I thought we solved that one, sorry.
Yeah, no, 32, Ron.
32, yeah.
Oh, okay. So I was thinking B, but I can never figure out if there was a difference or not, because we're below this significant confidence level, or the sit level of significance, right? With the 0.9.
So the
No, I
P
think it's
low,
higher.
so you reject the null.
Oh, it's lower. Yeah, that's not 0.5, it's 0.2.
At 0.10.
No, it's either B or C.
Okay. So that's where I'm like, oh, is this the
Right. Let me think.
no difference?
There is sufficient evidence. Cost 14 days in advance. No difference. Wait, did they conclude there was a difference? Let me see. That's what we need to look at the data.
Oh, there it is.
Oh yeah, there is a difference. There is definitely a difference. So
How do you know?
you look at the data and there's a difference. There's minus 57 or plus, you know, plus the.
Oh, minus 4.4310 versus 53.65.
So there is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 19. But there's no yeah, it's the second one. It's got to be, right?
Yep.
Okay. I can submit mine.
Sure. Thank you. I need to plug myself in. Sorry, I'm not like on 2%. How does it look?
It's looking good. Oh, I got one wrong. That's kind of weird.
Which
It
one?
says what's appropriate. It asked, well, I got the one wrong. I forgot to change it to, I'm sure you guys got it right. It's
Which number?
sorry, I'm having a hard time with my scroll here. Okay. It's for number 11. I put p-values larger than sigma, but I think you're right that it was the A is equal to 0.05.
And we got everything else right?
The next one that was wrong was, we got a lot right. Number 22. It's saying I put A, confidence interval for mean when sigma is known.
Okay.
What's weird about that though is we used that formula and we got the correct answers out of that. So that's kind of weird.
Wait, so what did you put? Confidence interval for
Mean when
Did
sigma
you
is
put known
known.
or unknown?
But that's not, it's not that one.
She put known.
Oh, okay.
So
All right. And is there another one that we got wrong?
Sorry, I'm writing them down, which ones I got wrong, so I can look back. Okay, and then the next one is, we got them all right, but a few of ones I got wrong. So they're all right, but 22 and
and 11.
and 11, yeah.
Oh, that's refreshing. Okay.
So, and 11 was A equals 0.05, right?
That,
Yeah, I should have put that one. You guys were right about
I
that.
haven't submitted that one. Here, I'll go ahead and submit real quick. Hopefully I didn't screw up on entering things.
No, that's what I'm worried about. I usually just wait until submit on the very last moment. 22. I don't know what to put for 22 if it's
Oh,
wrong.
see, I screwed up on number 4. What was number 4 supposed to be?
Let me have a look. Question
Sorry.
4. Confidence interval for mean when sigma is known.
The very bottom one?
Yeah, is that what you
Well,
put?
I put confidence interval for the difference of means using independent samples.
So this, you put letter C?
Yeah, and that one was the right one.
Correct. Okay. See,
Mhm.
I messed that one up.
Yeah,
Okay.
me too.
5, 6. Those are all right. Those are right. 11 is not A equals 0.05.
Oh, so that one either. Okay.
It is not that one, and it is not. We picked, which one was the one that you picked, larger or less?
I picked the larger one, so p-value could be less than level of significance.
I think it is. After we've been talking about it, that makes sense now.
P-value is less than A. I can submit that, so
Okay,
P-value.
hold on. Let me get the, make sure the rest.
Yeah, I'll look at the rest. So P-value is less than A. So that's
Yeah.
number 11. P-value is less than A.
And
Number
then
22.
22 is incorrect again.
Oh, so what did you try for 22?
Now we tried confidence level is known and unknown. It is not either of those.
So it has to be confidence level interval.
Either
For the mean
dependent or
differences.
independent.
Did we decide if it was dependent or independent? Let's have a look at the data.
Let's take a look. Oh, they're independent because the sales in New York have nothing to do with the sales in Los Angeles for cars. I think it'd be C.
Hey, and so I clicked on the wrong one on 29. What is 29?
Let's have a look.
9 is
32.
dependent samples test.
Dependent samples. Okay, I had one sample T. I must just clicked it wrong.
Okay, shall I go ahead and pick? Can I go through and double check? Just
Yep.
because then we can have alternate. Then we can all go in and hopefully get everything.
That works for me.
Yeah,
Fine.
that's good. Yeah.
So 1 true. 2, we are 90% confident that the true mean heart rate is between 45 and 105.
Yeah.
3, Yes, the distribution of means for each sample is normal since the data has been determined as normal.
Yes. Yeah.
Mhm.
4, confidence interval for the difference means including independent samples. That's one we're trying out.
Try that one. Yeah.
Yeah. 5, obtain the balances of 90 bank customers rather than 30. 6, 1.96.
Yes.
Lower bound 998.040.
Yes.
And then 1001.96.
Yes.
Question 9, 38416. Sorry.
Yep.
10, it was the last one.
Yep.
Hypothesis 1215 eats the other one. 11, p-value is less than a. We're trying that one out, right?
Yep.
12, yes, it is enough. The data for each apartment building are bell-shaped with no outliers.
Yes.
13, committed a type 1 error.
Yep.
It was a good call. I'm surprised we got that one.
Good.
Reducing the probability of a type 1 error. We
Yep.
increase. Reject hypothesis.
Yep.
Question 15. 16, paired sample t-test.
No, I had independent sample t-test.
Oh, okay. Oh, that's good. 17, dependent sampling. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
Yes.
18, confidence interval for mean when sigma is unknown.
Correct.
19, 2.025.
Yes.
11.168 lower bound.
Yep.
15.217 upper bound.
Yep.
22, confidence interval for difference of means, including independent samples.
Sure. That's the one we're going to try.
Oh, that's the one we're trying.
Yeah.
That's the one we're trying.
Yeah.
Yeah, and if not, it's definitely the other one.
Yeah,
Because
exactly. There's nothing left.
calculate. Oh, sorry. Lower bound minus 423.185. Oh, 158. Sorry.
Yeah.
So minus 423.158. Upper bound 5417.256.
Yeah.
25 ANOVA. 26 7.978.
Yep.
P-value 0.002.
Yep.
28, there is sufficient evidence to conclude the mean bone density of at least one of the groups is different.
Yeah. Is that
The C. No, D.
That's D, yeah.
29, dependent samples test.
Yeah, that's the one I got wrong.
Oh, yeah.
Yeah.
30, 1.685.
Yep.
31, 0.096.
Yep.
And then 32, there is sufficient evidence to conclude there is a difference in the mean cost of tickets per 14 days.
So B. Yeah.
I'm going to submit that, and then hopefully those 3 that we're checking out will be good. If not, we know. 100%! So,
Awesome.
we go through with you.
So the one 11B and 20C were both correct.
So
Okay.
let me say 11. So 11 is p-value is less than a. And then 22 is confidence interval for the difference of means using independent samples.
Okay. Okay. Okay, are we good to go? Okay.
Hello? Oh, I don't know where everyone went.
Yeah, mine froze. But are we all good or
Yeah, I'm happy.
okay?
I wonder where Christina went.